we will start today's session. Okay, yesterday we have been dealing with the projection. Okay, and you know what is orthographic projection. In orthographic projection, what are all the forms available? You know, you have first angle projection, second angle, third angle, and fourth angle, right? So you know first angle projection, especially in detail. Okay, how the views are placed. Okay, the front view is above the reference line, top view below the reference line, and side views always come along with the front view. So the left side view, as for first angle projection concerned, it will come to the right side. Okay, so you can in third angle projection it is ulta. You will be having the top view on the top, front view below the reference line, and the side views along with the front view below the reference line. The difference is the left side view comes on the left side itself. Okay, left side to the front view, but the whole front view left side view will come below the reference line. Okay, that is the difference. So you will see the symbol of first angle projection. Symbol of first angle projection. Symbol of first angle projection, if you see, you know already I told you, make a note, yeah, frustum of a cone, the frustum of a cone is, as per the B.S.ABDUR, is a frustum of a cone placed such that its axis parallel to both VP and HP, such that its axis parallel to both VP and HP. Right? We will have frustum of a cone. We have seen, say, this is the frustum of a cone. Okay, it will have an axis. So the axis is parallel to VP and HP. Okay, the cone is placed like this. Then from this we will be drawing the symbol of the first angle projection. Symbol of the first angle projection. You can see here the front view, since it is parallel, axis is parallel to VP, and the front view will be what? What you will be drawing in your title block, the symbol first angle projection. The front view of this frustum of a cone will be seen as a like this. Like the front view will be like this. Isn't it? The front view will be like this, and the side view, suppose the same frustum of a cone, if I look at in the left side, okay, the left side, you see the left side, I can see two circles. Okay, one circle is two concentric circle, one is smaller circle, another is bigger circle, depends upon the base, two bases. Okay, I have a smaller base and another bigger base I have. Okay, two base, for these two bases I will have two circles seen in the left side view. In this left side view I can see both the circles. Okay, both the circles of the frustum, both the circles of the frustum of the cone. It will be seen as fully visible circle. Right, it will be seen as a fully visible circle. So where I have to draw that two circles? I am viewing to the left side, I have to draw the two circles here. Right. The left side view will be drawn to the right side of the front view. So this way it will be representing the first angle projection. Now you will understand the symbol of the projection. Okay, the front view will be drawn as it is, right? Then the side view, that is the left side view, will be on the right side. This is the left side. So you should not draw this. Similarly, I can draw the another view, right side view. If I draw the right side view, you see the right side view, I can see a bigger circle. The right side view, I have to look at the frustum to the right side. The bigger circle, I can see, I will see a smaller circle. The bigger circle is fully visible. The smaller circle, the bigger circle is fully visible in the right side, from the right side. Bigger circle is fully visible. The smaller circle is hidden. Okay. While I am viewing from the right side, the bigger circle is put in, the smaller circle will be seen as a hidden circle. So I can draw the right side view as a hidden and a bigger circle as a visible one. Right. So this you should not represent in your first angle projection symbol. So the first angle projection symbol will be the front view and the left side view, which will show both the bases of the frustum of the cone visible. Right. So any symbol I am representing, both the faces will be visible. So I have to represent the first angle symbol like this. Right. So the same way, the frustum of the cone in the third angle projection, what will be the symbol for this? Yeah, this two circles will come to the left side. Okay, the same left side view, what I am viewing, I will be drawing to the left side itself. Okay, the same two left side view, this left side view will come to the left side itself as for third angle projection. So according to the symbol itself, whatever symbol you have in your drawing sheet, okay, in the title block, okay. First of all, you have to read that whether the drawn drawing is drawn as per the first angle projection or third angle projection. It is not written. It is only the symbol will be represented in any technical drawing. Okay, you have to know the symbol whether it is a first angle projection symbol or third angle projection symbol. So to represent the symbol, a frustum of a cone will be taken and it is placed. The axis is placed parallel to both HP and VP. Right. Projection of a point. First of all, as the second unit, this is starting of the second unit. Okay, in the second unit we have the orthographic projection of points. How we will be projecting the points? We will be using the four quadrants. Okay, in this portion alone, we will be using the four quadrants. Right. So the point will be placed in all the four quadrants. You are asked to project the point and you are asked to draw the front and top view of the point. Right? You are asked to draw the front view and top view of the point. The position of the point will be given in your problem. Right? Point is placed such that, okay, it is above HP, it is in front of VP, right? Something like that. You see, for these positions, you have to make a note of this position. Before that, make a note, what is a point? Point is an dimensionless entity, right? Point is a dimensionless entity. Then you go to the positions. Positions. See, two-dimensional algebra. You know, this is the vertical plane. This is the horizontal plane. Whatever point I am placing in this quadrant, you know this is the first quadrant, this is the second quadrant, third and fourth quadrant. Right. The observer will be here. You know. Okay, what is the position? Suppose I have a point here, what will be, how I can define the point? How I can define the point? It is above HP, make a note, it is above HP and in front of VP. Right, it is a position in the second quadrant. Above VP, right, behind VP. Right. Similarly, if a point is here, it is below HP. You make a note. Make a note in your notebook. Parallel, you make a note. Whatever I am writing, then below, behind VP. Right. So, what point if you place the fourth quadrant, the position will be given like this. It is below HP, in front of VP. Right. Is it clear? Take a problem. A point A 20 mm above HP and 30 mm in front of VP. The point A is placed 20 mm above HP and 30 mm in front of VP. Full stop. Draw the projections of the point. Draw the projections of the point. Draw the projection in the sense, draw the front view, top view, right? Draw the projections of the point. You see here, above HP and 30 mm in front of VP. So it is like this. The point A I am having. This is my point A. It is placed like this, straight. So the distance you can see, this is 30 mm. It is in front of and it is 20 mm above. Right. So point is 20 mm above and 30 mm in front of VP. Now we have to project this. This is my VP, this is my HP. To perform the projection, you know, okay, I can project point A to vertical plane. Whatever projection I am obtaining on the vertical plane, it is front view, you know. So the projection I will obtain here, exactly the projection I will obtain here for point A. So what is the notation I have to give? It will be a small letter with dash. So this is a projection I am obtaining. So far front view will be notating it with a small letter with dash. Okay. So similarly, the same point and top view of the point will be obtained on the horizontal plane. Okay. Any view obtained on a horizontal plane, it will be a top view. This top view notation, the top view exactly, it will be fall here. So the top view will be notated as small letter without dash. Right. Make a note. Make a note. Make a note. Front view will be notated with small letter with dash. Small letters with dash. Top view, front view notated with small letter with dash. Top view notated with small letter without dash, right? Similarly, side view, we do not side view, we will be using later. Side views notated with small letter with suffix 1. Okay, and the side view will be notated A suffix 1, B suffix 1. Okay, the side view will be notating like this, right? Now this is a setup, it is in a 3-dimensional one. You are asked to draw the 2-dimensional view for this point what it is placed in the first quadrant, right? So, yeah, 2-dimensional view, how you can draw it? What is this? The intersection of these two planes. The intersection of these two planes, it is X and Y. So how you will be drawing the front view and top view? So this is the one is wanted. This is, in your problem, you should not draw this setup. The projection is wanted. You have to draw just the projection of the point. Okay, this is rough work you have to do it, but in your drawing sheet, the answer should be the projections of this point. Okay, first of all, you have to draw the reference line for this problem. Right? The reference line should be drawn always as a dot H line. So this is the reference line. You know the front view and top view. While I am rotating this horizontal, what I should do? To make it in a planar shape, I have to rotate this horizontal plane 90° clockwise. Okay, always I will be rotating the horizontal plane 90° clockwise. Okay, as for our setup, what we have seen yesterday, right? So it is 90° clockwise. It is rotated. Then I can say that in a single planar shape. So A dash and A, that is front view and the top view, will be on a same line. Okay, that is nothing but a projector line of the point. Okay, so what you have to do, you have to draw a projector line first of all. Okay, this is a projector line. Right, this projector line should be very light, should not visible. Right, so you see here where I have to show my front view. So both front view and top view will fall on this projector line. Okay, I have to mark on this projector line where I will have A dash. How much distance above the reference line? 20 mm above the reference line. I can mark this neatly and darkly. You have to give a point 20 mm above the reference line. So you have to rotate it. See here, this is A dash. Right. Similarly, the top view will be below the reference line. It will be 30 mm apart from the reference line. So from here, the top view I can mark it for 30 mm. So it is A. This is the projection you are asked to draw. Okay, this is the one you have to draw it. Right. So is it finished? The problem is finished. Still what you have to do? What you have to do, it is not still finished, just you have given the projection. Whatever problem is given, you have to show the data given in your problem. What are the data given? Two data. There is 20 mm and the 30 mm is given. That you have to dimension it and you have to show it. You know to dimension. You see, I am dimensioning this. This is 20. This is 30. Say neatly, you have to show the dimension in one side, show the notation in the other side. Okay, whichever should be dark, A dash and the point alone should be dark, and the reference line and the projector line should be a light one. So, clear? Great. Take the next problem. Project the following points on a common reference line. Project the following points on a common reference line. Subdivision 1. Following point A. Subdivision 1, point A. 15 mm above HP, 20 mm behind HP. Point B. Subdivision 2, point B. 20 mm behind HP. Point B, 20 mm below HP, 30 mm behind BP. Point C, point C, 15 mm below HP, and 30 mm in front of B. Point D, point D, 20. 10 mm above this B, point D, 10 mm above this B, and on BP, point E, point E. Both on HP and BP, both. I have a common reference line. Okay. So I have 5 subdivisions. What is the first subdivision? What is the position? Okay. So the rough work you will be doing. Okay, you should not have it. A rough work you will be doing. Okay, the rough work you need not have a 3-dimensional one. It is simple. You can have it in a 2-dimensional also because it is a point. Okay. You need not try a 3-dimensional. You can have a 2-dimensional. What is the first subdivision? 15 mm above and behind. It falls on which quadrant? Second quadrant. So the second quadrant I can draw it like this. You know the second quadrant. The point is 15 mm above. This is 15. This is 20 mm behind. Right. So you know this is a vertical plane. This is a horizontal plane. Right. So what I have to do, I have to perform the projection. Okay, I have to perform the projection where I will have the front view. I will always obtain the front view on the vertical plane. Right. So the front view, while looking from here, the front view will be obtained here on the vertical plane. So it is nothing but my B dash. Okay. So the top view will be obtained on the horizontal plane. While looking from the top view I will obtain here of this point B, that is B. So this is the one. Then what I have to do to make it on a planar sheet? I have to tilt the horizontal plane 90 degree clockwise. Clockwise in the sense I have to rotate it like this. What will happen? This plane also get merged with the vertical plane. So I will have my B dash and B in one side. I will have B dash and B in one side. So I can draw a projectile line. I can draw a projectile line. See here. So from this is going to be my reference line XY. From reference line, my B dash will be 15 mm above. So I can mark 15 mm on 15 mm. I can mark my B dash. By rotating this horizontal plane, this B also come above the reference line. That will have a distance of, from the reference line, it will have a distance of 20 mm. So 20 mm from the reference line, I can mark B. From the reference line 20 mm, you will mark B. Then you have to dimension this neatly. See here, I have to dimension this. This is 15 mm. Then I have to dimension this. See, this is 15. This is 20. Right. Neatly you have to dimension it. You see each dimension will have a gap 10 mm. You have to maintain it. Right. So the second subdivision, how I have to project it. It is 20 mm below HP and it falls on which quadrant? Third quadrant. So it falls on third quadrant. You see here. Point is 15. 20 mm below HP. 30 mm. Okay, 30 mm behind VP. So this is 20 and this is 30. Right. So the point I have is CRT. B. We already have. So this is A. This is C. I will have this as C. Capital C. So by projecting this is vertical plane. This is my horizontal plane. By projecting this, I will obtain my front view here on vertical plane. That is C dash, small c dash. Okay. The top view will be obtained on the horizontal plane. That is small c. Okay. This distance. This is my reference line XY. The distance from the reference line, it will have 20 mm. C dash. This will have 30 mm. Right. C. So how I will have the view? I have to rotate the horizontal plane 90 degree clockwise. Right. So the C will come above the reference line. C dash will come below the reference line. So I can draw a common projectile line. You have to neatly, you have to place it. Okay, evenly you have to give the space. Right. Draw the projectile line. See here. C dash is 20 mm below the reference line. I can mark 20 mm. C dash. And it is 30 mm. It is going to be, the C is going to be this much distance. Okay, 30 mm. It is above the reference line. So it is 30 mm. This is my C. Right. Is it clear? So I have to dimension this. Dimension this. This is 30. This is 20. Right. So then, with third subdivision, see here, the third subdivision is, it is 20 mm. 15 mm below HP. 30 mm in front of VP. Right. This 30 mm in front of VP. If the point falls on fourth quadrant, the fourth quadrant I can draw it. It is going to be my fourth quadrant. So this is my HP. This is my VP. The point is 15 mm below and 30 mm in front of. Okay. This is my point. This point is D. Capital D. So by projecting this, the front view will be obtained on the vertical plane. By projecting this, I will obtain. Okay, this is, make a note. This is 15. This is 30. Okay. So this is my xy. So this is the d dash or d dash. Whatever you are obtaining a projection on vertical plane, that is with that front view. This is my small d. Now, by rotating the horizontal plane 90 degree clockwise, both the views will fall below the reference line. Both d and d dash will be below the reference line. We draw a common projector line. See here. So it will be d dash is from the reference line. D dash is 50 mm below. I can mark d dash. It is 15 mm. So from the reference line, d will be 30 mm, but it is going to be below the reference line. While it is going to be below the reference line. So from the reference line, d is 30 mm. So d is 30 mm. Again, it is below the reference line. So I can dimension this. Horizontal plane like this, vertical plane like this, right? So it is, the point is on VP, so the point is on VP and 10 mm above HP. The actual point itself, it is 10 mm and it is on VP. This is VP, this is HP. The point itself, this is my E. Right? So where I will have my front view in this position, the front view will be on the VP. Okay, the projecting point is also on the VP. Okay, so the front view will be on the same place itself. Okay, on VP I will obtain the front view on the same place itself. So that is my E dash. Right? Where I will obtain my top view? Top view will be on HP. I have to obtain by projecting this point E, which is on VP. So the top view will be obtained on where? Horizontal plane on the reference line. That is not origin, that is the reference line where it is intersecting. That is the reference line XY. Right. There itself I will get on the reference line. The top view will fall. Okay, is it clear? Point is on, actual point is on VP itself. Okay. So by projecting the point, the front view will be on the same place itself. I will obtain the front view on VP. By projecting the point which is on VP, the top view will be obtained on the reference line. It will fall on the reference line. Yesterday I told you the board. The board is on VP. Okay. When I am looking from the top view of the board will fall on the reference line. Right. The same way the top view of the board will fall on the point will fall on the reference line itself. So on the reference line I can mark a point. I can mark a projection, that view. That view is nothing but my top view. So that is my E, small e. So this E dash is above the reference line. Okay, it is on vertical, it is above the reference line. So it is, how much distance it is above? 10 mm. So 10 mm, I can mark E dash. Right. So if I mention this, so it is a 10 mm gap. In 10 mm gap, 5 mm to arrow heads placing is difficult. So how I have to dimension it? I have to place the arrow heads outside. gap itself it is 10 mm. So I cannot place two arrowheads of 5 mm height. So I have to show the arrowheads outside. So the dimension is 10 mm. Right. So what about the next one? Both on VP and HP, where the point actually is on the reference line itself. Both the views will be on the reference line. Neatly you can mark it. So I can mark F and F dash. F comma F dash will fall on the reference line itself. Okay. Right. So for points alone we will be using all the 4 quadrants. Hereafter we will be proceeding with only the first angle projection. So all the objects, okay, lines, planes and solids will be placed only in the first quadrant. Okay. This is orthographic projection of straight lines. Straight line. Right. So what is straight line first of all? Straight line. Suppose I have 2 points. Okay. I can define by 2 points. The straight line can be defined. Okay. Line joint is straight. Line joint, straight line. So I can join the points like this. Is it a straight line? Shortest distance between 2 points is known as a straight line. Okay, make a note. The shortest distance between 2 points. 2 points. Shortest distance between 2 points is a straight line. It's called a straight line. So other way I can define, if a point is having, I have a point. Okay, the other way I can define a point, if it moves linearly along, okay, if it moves linearly, then it is a straight line. Okay, a point moves linearly. Linearly in the sense, so this is, the curve is not linear, it is a non-linear one. So I have a 2 axes, I can say, conveniently I can say, this curve is a non-linear one. This is a linear one with respect to both the axes. So if a point moves in a linear fashion, then it is a straight line. It forms a straight line. Right. Of straight line in the first quadrant. As I told, okay, hereafter we will be using only the first angle projection. All the objects will be kept in the first quadrant itself. Right. The first quadrant, it is a first angle projection. Front view will be above the reference line, top view will be below the reference line. Right. So what are the positions available? We'll see. First of all, I'll consider this as a straight line. Okay. This as a straight line. So this wall, vertical wall, it is a vertical plane. So the floor, it's a horizontal plane. So you tell me the position. Suppose what is the position of this with respect to vertical plane and with respect to horizontal plane? No, sorry, not. Parallel to, with respect to, so it is, listen all of you, listen all of you, the straight line is placed above the reference line and in front of the, above the horizontal plane and in front of the vertical plane. Why? It is on the first quadrant. I told clearly it is on the first quadrant. It is placed in above the horizontal plane and in front of the vertical plane. I am asking with relation to vertical plane and horizontal plane. It is parallel and vertical to horizontal plane. So I can write the first position. It is parallel to vertical plane and perpendicular to horizontal Right. Right. So what would be this position?
Parallel to horizontal plane,
Perpendicular to vertical plane. Whatever this with respect to both. Parallel to both. Okay, parallel to HP and VP. Fifth one. What is this one? Inclined to which plane? Horizontal plane, and how it is placed? Parallel to VP. Okay, it is inclined to horizontal plane. So it is inclined to horizontal plane. That inclination, I will say it is theta. I will say right. And parallel VP. So what is this orientation? It is parallel to HP and inclined to VP, right? It is parallel to inclined to VP. So that inclination I will rotate it as phi, and it is parallel to HP. Right? One more position you have. 4, 5. Right? You see here, this is the other orientation. Okay, in this only most you will be getting problems. You see here, what is this? It is inclined to both. Okay, it is inclined to HP and it is inclined to VP. Right? So I can say it is inclined to HP and VP. Right? Both, you can say inclined to both HP and VP. Parallel to VP and perpendicular to HP. So here, this is the orientation, you know, right? What I am going to deal. It's like this is the orientation. So the line is parallel to VP and it is perpendicular to HP. Right? So the line length will be given in your problem. In problem, the line length will be given and line, so one end position is given. The line will have two ends, one end position will be given. The one end position I can say, you know, it is definitely, it is in first quadrant, it is above and it is in front of. The other case it can be touching the reference line. Okay, the above distance is 0, but in front of distance of one end will be given. Okay, that is another case, right? So the one end's position will be given and the line length will be given and the line orientation will be given in your problem. Whether it is parallel, it is perpendicular, it is inclined, and one end's position will be given. So the position will be, since it is in first quadrant, it will be above and in front of distance will be given of one end, right? So you are asked to draw the projections of the line. So you have to draw the front view and you have to draw the top view. Here in front view and top view, you will be two ends, you will be having 2 points, end points, you have to project it and you will be getting a projections. Right? See here, take a problem. A line AB of length, a line AB of length 50 mm, 50 mm has its end A 10 mm above HP, has its end A 10 mm above HP and 15 mm 10 mm above HP and 15 mm in front of VP. 15 mm in front of VP. Great. Draw the projections of the line. Inside bracket you write projections in the sense front view and top view, right? Front view and top view. So draw the projections of the line if the line is parallel to VP and perpendicular to HP. If the line is parallel to VP and perpendicular to HP. Great. All the conditions are given. You can see here, this is the orientation, this is the line having length 60 mm and the end A is here. So it is 10 mm above and 15 mm in front of VP, okay, the end A. And it can be like this, the end orientation here, the line can be like this, but it is given it is parallel to VP and perpendicular to HP. Right. So you are asked to draw the front view and top view. What is the front view will be? Front view, a straight line, I can see it as it is. Right. A straight line will be projected as a front view. To what length? The front view length of the straight line, it will be 50 mm. Why? The length is 50 mm. Okay. And why it is the same length I am obtaining on the front view also? Since it is orthogonal, right? Since it is parallel, I can say line is if it is parallel to any one of the plane. If a line is parallel to any one of the plane, I will obtain the true length of the line, that is the true dimension of that line in that plane. Right. If a line, since the line is parallel to VP, so the true length will be obtained in VP. Okay. In VP I will have the front view. Right. So what will be the top view here? Point. Okay. Both the ends will be seen as a point. Okay. Since it is perpendicular, I can say if a line is perpendicular to any plane, I will obtain a point as a projection in that plane. Right. Clear. You make a note. The true length of a line is obtained in a view only if the line is parallel to the projection plane. Only if the line is parallel to the projection plane. To solve this problem, okay, first case I will draw it in detail. This is a location of the end of a line is given, that is say A, line AB, A, end A. So and the line is vertically it is standing. This is my end B. So the line length is given. So this is 15 and this is 15 and this is 10 mm is given. So suppose if I project this, where I will obtain the front view I will obtain it here. Okay, the front view will be seen as a straight line, okay, with the same length, true length. What is the notation I give for the front view? This will be my A dash, this will be my B dash. Okay, so the top view, it is obtained on the horizontal plane. I can rotate it here. It will be seen as a point. Okay, the whole line will be seen as a point. This is my, I can see A and B both together as a single point. So now the one more thing is, see here, if I have a point here, I am looking at the straight line here, I am looking at the straight line from the top. So this is my end A, this is my end B. So which end I can see? What end? This is my end A, this is my end B. I can see only B. The A end is not seen. Okay, it is hidden while looking from the top. Okay. So while looking from the top, I can see only this end B, this end A is hidden. So the hidden details I will be showing with a bracket. I will be showing with a bracket. So which is hidden here? B can be seen, A is hidden. So I will be showing with bracket. The hidden details I will be showing with bracket. Right. This is the top. Now I can rotate this horizontal plane to 90° clockwise and I can draw it on a. So this is the one. Yes. Then I can draw a reference line. Right. So from the reference line where I will have my front view, 10 mm above the end I have to mark it. First of all, what you can do, the end location is given now. That end location, first of all, you can mark it. This is the first angle projection, you know. The above distance you have to mark it above the reference line. Below distance you have to mark it below the reference line. Sorry, in front of distance you have to mark the below the reference line. There will be only two data given for the position of end. That is an above data and an in front of data. The above distance you have to mark it above the reference line. In front of data you have to mark it below the reference line. Above data is 10 mm. In front of data is 15 mm. Okay. So rule 1 you can follow. Above distance you mark it above. So here the above distance I can mark it. This is my A end A dash. And in front of distance is 15 mm. I can mark it end A. Right. This is the ends projection. One ends projection. Then you know it is parallel. Since it is parallel to VP and it is perpendicular to HP. So in VP I will obtain a straight line, true length as a front view. So from here the true length for the length of the line 50 mm I can show the front view. So this is my front view. So what will be this notation? It is B dash. So this here I will have A and B together. So A is inside bracket. It is hidden. How I can easily draw it? You can draw a projection here. So by looking to show the hidden details of the top view, you have to look at the front view from the top. Front view you can look at from the top. I can show the hidden details for the top view. So if I look at the front view from the top, I can see only B. I cannot see A. So this is hidden. So that hidden details I have to put bracket. To put bracket for the front view, you have to look at the top view from the bottom. So I can see from the bottom. I can see both the ends. I can see here. So nothing is hidden in the front view. Right. So this is the projection of the. What is the data given for this? That you have to dimension it. So the data given for this is this and this. The dimension it all together. It's 10 mm. Right. So this is my 10 mm. This is 50. I can dimension it like this. But the 10 mm gap I cannot place 2 arrowhead. So the other outer arrowhead itself, it gives the meaning for dimensioning. See here, the front view. So what is the plane you have above the reference line? As for first angle projection, above the reference line, what plane you have? Vertical plane. So I will be representing VP along with reference line. I will be showing VP. Below the reference line, what plane you have? HP. As for first angle projection, okay, all your problems along the reference line will be representing with VP and HP. So above the reference line will be VP, below the reference line will be HP. This is how you have to show your projection of a straight line. The reference line with a dot one, XY you have to represent, and VP and HP you have to show it. Right. So all your problems, then you have to show the projection. Next case, the line AB, a line AB of length, a line length 50 mm has its end A 10 mm, a line AB of length 50 mm has its end A HP and 20 mm above HP and 10 mm in front of VP. 20 mm above HP and 10 mm in front of VP. So shall draw the projection of the line if it is parallel to HP and perpendicular to VP. Parallel to HP and perpendicular to VP. So this is how the point line is projected. Okay, see here, this is the end, the nearest end is given, the end is 10 mm, 20 mm above and 10 mm in front of, this is the end A, right, this is an end A, and the line is placed like this, it is parallel to HP and perpendicular to VP. So where I will obtain my true length? Below HP. Below the reference line. On HP I will obtain the true length. Okay. So what will be my front view? Point. The front view will be a point. Here a front view will be a straight line. Now we will obtain a point as a front view. We will obtain a line as a top view. Right. That line will have the same length, true length. Since it is parallel, the line will have the same length. Is it clear? So the same way you have to draw it. Instead of this, we will be having point here and a straight line below the reference line. You do it as a homework. The next problem, draw the projection for this. The next one, this is the thing. Okay, this is the case I am going to take. Okay, the line is parallel to both HP and VP. For a line PQ of length, a line PQ of length 50 mm, 50 mm has its end A, one end A, has its one end A 10 mm, 15 mm above HP and 15 mm in front of VP. 15 mm above HP and 15 mm in front of VP. Such that the line is parallel to both HP and VP. Such that the line is parallel to both HP and VP. Stop. Draw the elevation and plan of the straight line. Elevation and plan of the straight line. What is elevation? Elevation means what? Elevation is another term I will use. Okay, civil engineering term. Okay, another term I can use it for front view. Okay, so plan in the sense from the top, if I see, I can see a plan. Okay, that plan is nothing but top view. Okay, plan, P-L-A-N, plan is top view. Right, it's nothing but, not get confused, it is nothing but front view and top view. Right, draw the elevation and plan of the straight line. So how you can draw it? So see here, in this case, this also you have to do it. See here, how it is. This one end is given, one end location is given. It is 15 mm above and 15 mm in front of, and the line is parallel to both HP and VP. Since it is parallel to both the planes, true length will be obtained in both the views. Okay, the same length, if I project it to VP, I will get this same one. If I project it to HP, I will get the same one. So how we can draw the projection for this? The reference line X, Y. So this is VP, HP. How to rotate it? Okay, one end is 15 mm. So you can draw a projector for one end. You can draw a projector for one end. one end A location is one end is nothing but a point, right? That location is given, it is 15 mm, sorry, it is P dash B, P dash B, right? So line P, it is P dash B. So both are 15 mm above and 15 mm in front of. So this is 15 mm above, 15 mm in front of. So I can dimension this. This is 15 mm. This is also 15 mm. Right. Plus here. Right. So this is the one end location is given. I have projected the one end. Now the orientation of the plane is given, that is the line is given, that is parallel to both. So in as well as in the front view also I will obtain the as a true length as a front view. True length will be obtained as a top view. So how it will be? It will be a line. It will be a line parallel to what? The front view. How will be the front view? In this case, the front view will be a straight line. The straight line will be parallel to the reference line. So parallel to the reference line, I will obtain a straight line. Okay, parallel to the reference line, I will obtain a straight line for a length of its true length. Okay, 50. Say it will be my Q dash. So clear? The same. This is my front view. The same thing I will obtain it on the top view. The top view also will be parallel to the reference line. So, okay. So the other end will have the location like this. So that also Q. So clear? So Q dash and Q is the other end. This is going to be my front view of the line given problem, and this is the top view of the line. So front view will be notated with dash, top view is without dash. Right? The line notation is given, that is PQ. So capital PQ. So it will be in small letters with dash and without dash. Right? So this is the projection of this problem given the next problem we take. The line MN, a line MN of length 50 mm, a line MN of length 50 mm, 50 mm. A line MN of length 65 mm, 65 mm is inclined 30 degree to HP, inclined 30 degree to HP, and parallel to BP, parallel to BP. Drawing projections of the line. If nearest n, m, nearest n, m, nearest n, m, 10 mm above HP, 15 mm in front of BP, 15 mm in front of BP. Okay, this is the other. See here. So I have a line of length 65 mm and the line is 30 degree inclined to HP and it is parallel to BP. This is how the line orientation is. Right? And it is parallel. And one end. The one end in the sense, the one end is the nearest end. So nearest end is the 15 mm above and 10 mm above and 15 mm in front of. Okay, the 10 mm above and 10 mm in front of is given. Right. You are asked to draw the projections, that is front view and top view. You see here, in this case, to which plane it is parallel? Vertical plane. In vertical plane you will obtain the front view. True length you will obtain, front view you will obtain. How it will be? It will be like this. 30 degree you have to draw a line with the true length of 65. Okay, 30 degree you have to draw a line with the true length of 65. So you tell me the top view. Top view will have a true length or apparent length. Apparent length. Okay, it won't have a true length. You see it is inclined. Since it is inclined, this end will be projected there, that end will be projected there. So what view, how you will obtain a view? A smaller length, straight line. A smaller length, straight line, and that straight line, how it will be? Parallel to which? Parallel to vertical plane is parallel to the reference line. So the whole top view will be obtained on the vertical plane. So it will be a shorter length of straight line which will be parallel to the reference line. In a front view, I will obtain a true length with an inclination of 30 degree. That inclination is nothing but a true inclination. The line's inclination, what is given in the problem, it is 30 degree incline. So in the front view, that 30 degree also, the same 30 degree I will obtain in the front view. That is called true inclination. True inclination. If a line is inclined to one plane and parallel to other plane, if a line is inclined to one plane and parallel to another plane, the true inclination of the line, will be obtained on a plane parallel to this line, on a plane to which the line is parallel. Okay. See here, listen all of you. This is a line. Okay, actual line M, it is on capital letters. You see here, it is inclined. It is inclined 30 degree. It is inclined 30 degree to the horizontal plane. Right. The projection of the line, it is obtained on the vertical plane and on the horizontal plane. Okay, the front view it is obtained on the vertical plane. That front view it will be like this. See here, this is my M dash and this is my N small m dash. Right. The top view, if I project it the line, it will be obtained as a straight line for a apparent length, shorter length, and this straight line what I am obtaining, it will be parallel to the reference line. See here, this is small m and small n. So this is my reference line. Right. By rotating this, I will have the front views and top view. See here in the front view, it will be the same true length will be obtained in the same true inclination will be obtained in the front view. Right? Is it clear? So you have to draw only the projections in your drawing sheet. The projection will be, you have to draw the reference line. Front view, okay, with a true inclination, this end M projection I can project it. The end M projection is 15 mm above and 15 mm in front of, right, this M dash M. So both are 15 mm above and 15 mm in front of. I can dimension this. 13 mm in front of VP, right? See here, this projection it is, since the line is inclined to VP, so the and parallel to, sorry, line is inclined to HP and parallel to VP, so I will obtain the true inclination and true length on VP. Okay, true inclination and true length. So the inclination, how you can draw it? The true inclination is 30 degree. So 30 degree to the horizontal. So I can draw a 30 degree line. Okay, so drawing 30 degree line. And what is the length I have to measure? 60. So true length and true inclination will be obtained on the vertical plane. So true length is how much? 50, 65. Okay, 65. You have to measure 65 mm length. 65 mm length you have to measure, and you have to mark this as end tap. So this is going to be my front view. Right. Top view will be. I can project the other end. How will be the top view? So the ends projection will fall on. Okay, any ends projection will fall on a same projector line. Okay, same projector line. So see here, M dash, if I draw a projector line, okay, on the same projector line, I will get my N dash, and N. Okay, on the same projector line, I will get my N dash and N. So what is this angle? You have to show it deeply. You have to show it using a compass. Deeply, you have to draw an arc. So I can show 30 degree here, and this length of the line is given. Okay, the data, these two data is given. 30 degree is given. The length of the line is given. That is 65. So the length of the line, true length of the line 65 I will have in my projection only in the front view. Okay, in the top view it is not 65, it is an apparent length. So this 65 you have measured. So this you have to dimension it. Keep your drafter parallel to this. Use your another scale to draw the extension line. So using that I can draw an extension line neatly perpendicular to the line which you are dimensioning. So this will be my 65 mm. Okay, the data whatever given you have to show it like this, right? So this is the projection of the line inclined to VP, HPN parallel to VP, right? If it is asked, you can show it. What I told, whatever problem is given, the given data you try to present it as dimension. If something is asked, you can dimension it. Okay, if something is asked, you can dimension it. See here, this is, what is this white line? What is this white vertical line I am drawing? It is a projector line of end M. It is a projector line of end N. So the distance between these two is nothing but the end projector distance. Okay, in some problem, so using this, the end projector distance will be given and the line length will be given. You are asked to draw the projections of the line. How you will draw? If I will give in the same problem, if I will give the end projector distance between the end projector, say it is 40 mm, and if I give the true length 60, if I give the true inclination, okay, if I give you the true inclination, can you find the true length? Can you find the true length? If I give to end projector distance, say it is 40 mm, I can draw two end projectors to 40 mm length, right? So the orientation is parallel to VP and inclined to HP. So I will have my reference line. So one of the top view will be definitely parallel to the reference line. So this is nothing but my distance 40. So this is my view 40, right? So what will be the front view? The inclination will be given 30 degrees. So I can draw a 30 degree line. Okay, I can draw a 30 degree line. Wherever it intersects the other projector, that is going to be my another N. Okay, so this is M dash. This will be my M dash. So if you have a problem, the true length will not be given. Okay. So wherever it intersects the other projector, so that will give you the other end. Okay, and so this angle, so in your problem, given data is this 40. Okay, this angle 30 degree. So you are asked to find the true length of the line. What will be the true length? You have to measure it. You have to measure this and you have to show the true length. This is going to be the true length, right? True length, you know, this is going to be the true length. In this case, I am talking about this case, right? In this orientation, this will give me the true length. Okay, this will give me the apparent length. That length is nothing but the end projector distance, right? This is nothing but the inclination is the true inclination of the line. Okay. So we will go to the next case. There are several cases only. Next case, the line AB, the line AB of length, the line AB of length 70 mm, the line AB of length 70 mm has its end A 15 mm above 15 mm above HP and 15 mm in front of BP. 15 mm in front of BP. Above HP and 15 mm in front of BP. First up, draw the projections of the line. If the line is 30 degree inclined to BP and parallel to HP. 30 degree inclined to BP and parallel to HP. So I can say this inclination is my theta, the previous one. This is called true inclination to HP. The line is inclined to HP and this inclination is line is inclined to BP. Line is inclined to BP. This case, you see here, the line is like this. The line is like this. See here, one end is given. It is both 15-15, and it is inclined. It is 30 degree inclined. So where I will obtain the true length and true inclination? I will obtain on the horizontal plane the true length and true inclination. That is nothing but my top view, right? I will obtain a straight line on my front view. So both will be, so the straight line will be apparent length, it will be parallel to the reference line. So clear, you need to want to draw like this. You want to draw like this? Okay. You see here, the line is like this. Okay, it is inclined and it is parallel. Okay, both this inclination of VP 5 and the true length will be obtained on the top view. Since it is parallel, I will obtain the true length there. Okay, so the same true inclination also I will obtain on the top view. So in the front view, the line, a straight line will be obtained with a shorter length parallel to the reference line. Okay, in the front view, a straight line will be obtained parallel to the reference line. Similarly, the reverse opposite way you will get. You see the projection just. The projection. Straight away, this is my reference line. This is VP, HP, straight. So without the diagram, you see what is the given first end is given 50 mm above, both above and below. So one end I can project it neatly. I can project one end. See here. One end I can project, it is 15 mm above, 15 mm in front of. So this is my A dash and A. Both are 15 above and 15 in front of. So this is right. Both the true inclination and true length will be obtained on horizontal plane, HP. So what I have to do then? I have to draw 30-degree line. Okay, measuring this, I can draw a 30-degree line. To what length I have to draw it? This is going to be my 30-degree. This is going to be my 30-degree. So what length I have to draw it? What is the length of the true length? Okay, 70. So you have to measure 70 from end to end. Right. I have to mark the other end. What is this? Is it? What is the notation of the other end? B. B dash or B? B. I am drawing the top view. It will be small letter without dash. Right. This is my B. So this is going to be my top view. This is going to be my top view. So this length is given. I can dimension this. So these are all the given data. Using this I can draw it. How I can get the front view? From the other end I can draw a projector. Okay. I can draw a projector line. Okay. Along this projector line only I have to mark the front view of this end B. The front view of this end B, where I will get? A dash location itself, that is the same height 15 mm. That is nothing, that's what I will have a straight line parallel to the reference line in this case. Okay, I will have a straight line with a shorter length, reduced length parallel to the reference line. So this is my B dash. So this is my top view and this is going to be my front view. Is it clear? Is it clear? Do you have any clarification? Right. Similar case, it is inclined to VP. Okay. This inclination, I would say, it is true inclination to VP. It is rotated as 5. So the true inclination only you will obtain on a view if the line is parallel to that plane. Okay. If a line is parallel to any one plane, then only the true inclination is obtained. Okay, if I am going to deal another case, the last one, the line will be inclined to both the planes, you won't obtain the true length at all. Okay, both the views you will be obtaining the apparent length. How to solve that? So you have a break. Right, is it clear? So far it is clear. This case, you should remember, right? Using this case only I am going to proceed to the next stage. Right, the line is inclined to HP and line is inclined to VP. Only inclined to HP and only inclined to VP. Right, the line is inclined to HP in this case and it is parallel to VP. So I will obtain a line, true length and true inclination on the front view on VP and an apparent length of shorter length as a straight line parallel to the reference line I will obtain on the top view. And if the line is inclined to VP, I will obtain a inclined to VP and parallel to HP. I will obtain the true length and true inclination in the top view. Right, true length and true inclination in the top view. And in the front view, I will obtain a straight line parallel to the reference line with a shorter length. Okay, that is an apparent length. Is it clear? Length is 70. Right. Okay, so I will deal. Okay. What is trace? We will see traces of a straight line. The line is, it is like this, okay, it is inclined to HP and parallel to VP. If the line, if it intersects, the original line, if it intersects the reference plane, wherever it intersects, the intersection point you will obtain on the reference plane, right? So that point, intersection point of the line with the reference line, that point is nothing but the trace of a straight line, okay? A trace is nothing but an intersection point of a straight line with the reference plane. Intersection point of a straight line with the reference plane. Then I have horizontal trace HP. Horizontal trace. Horizontal trace in the sense what? If the straight line intersects with the horizontal plane, that point is nothing but a horizontal trace. The intersection point of a straight line with the horizontal plane is termed as horizontal trace. Horizontal trace HT, normally it is denoted as HT. The intersection point of a straight line with the horizontal plane is termed as horizontal trace. We have another term called vertical trace. Vertical trace is similarly the intersection point of a straight line with the vertical plane is termed as vertical trace. Okay. Generally, trace is nothing but the intersection point with the with the reference planes. Okay. A straight line, if I extend it, so normally it is like this. It doesn't intersect. So I have to extend it. Then only I will get an intersection point on the reference plane. For this, I need to extend my straight line, if necessary, and I will have an intersection point where it intersects. That location is my trace. If it intersects horizontal plane, that is horizontal trace. In this case, you see, it intersects only horizontal plane. It will intersect vertical plane? No. Since it is parallel, it cannot meet the vertical plane at all. So it will have only the horizontal trace. It won't have a vertical trace. In this case, I can say the line is inclined to VP. What it will have? It will have vertical trace. If I can extend this, okay, it will go and meet the wall, the vertical plane. So that location, intersection location is nothing but my vertical trace. Here in this case, since it is parallel to HP, I don't have a horizontal trace at all. So it won't intersect my horizontal plane. Right? So the trace, remember, let's see here how to mark the trace. So I have to extend for this, I have to extend the original line. Okay, where it will give. But in your problems, you will have only projections. Okay, from the projection, how I can obtain my trace? How I can obtain my trace? See there, the horizontal trace in this case. How I am going to obtain? See here. This is inclined to HP and parallel to VP. So this is the original line. I have to extend the original line, MN. So if I, on the same fashion, if I extend it, where it will meet the horizontal plane. Okay, somewhere here. It meets, isn't it? So the plane I have to, this plane is, this is representation, I can extend this plane. Where it intersects the horizontal plane. Okay, so this location is this point is my trace. Since it intersects horizontal plane, this is my horizontal trace. Right, it doesn't have a vertical trace at all. Right, so in my problems I will have only projection. How I have to mark the horizontal trace? Anybody, can I mark the horizontal trace here? This is projection, this is not an original line. From this projection, how I can mark the horizontal trace? How I can mark the horizontal trace? In this problem you have the view. Okay, that view you have to get the horizontal. Now what I can do? I can extend the front view. Okay, I can extend the front view on the same fashion. See, somewhere here. Will make. Then what I have to do? So I can extend the front view and it will meet the reference line. Just by extending the front view, it will meet the reference line. So I am extending the front view. It is meeting the reference line somewhere. So I can mark this where it meets the reference line as small h. Since I am extending the front view as small h. Then what I can do to get this horizontal trace? I have to draw a vertical from this h, say this is h, small h. I have to draw a vertical line from this small h. It's nothing but, the vertical line is nothing but here, this. From h, I have to draw a vertical line. Then what I have to do to end up with horizontal trace location? I have to extend the top view. Okay, I have to extend the top view horizontally. It will end up, it will intersect this vertical line. That location is my HT. So if you have to extend the top view on the same fashion, it will meet the vertical reference line. That location I can mark it as small t. Right. Then I have to draw a vertical line there. Then I have to extend the my front view. Where it meets, it is my vertical trace. So in this case, you see, previous case, do you have a horizontal trace or vertical trace for this? It is parallel, both parallel. This case, the line is parallel to both HP and VP. I don't have traces. Right? It doesn't make the reference line. Here you have a trace. It is like this. Okay, vertical parallel to VP and perpendicular to HP. Do you have a trace? What trace you will have? What trace you will have here? HT. Right. It is this case. No, it is like this. Right. I can extend and it will meet the horizontal plane. Wherever I have my top view, okay, that is the location of my horizontal plane. The problems you will be getting in this case. Okay, carefully listen. See this line is both HP and VP. So this is the case. The line is inclined to HP and inclined to VP. Straight away from a problem we will solve. Here, as usual in this case, in any view, okay, in front view as well as in top view, I don't find a true length. It is not parallel. It is not parallel to HP, it is not parallel to VP. For both the planes it is inclined. Okay. So I don't get a true length in any of my view. Okay. So how to draw the final projections for this? Okay, you have to solve it step by step. This is theta. AB line length. So you will be writing hereafter like this the data. AB is nothing but the true length. It's given as 70 mm. Right. 75 mm. Then the lines one end location is given. That is end A. End A is how much? Above 15 mm. Above. Okay, I will indicate like this. 15 above. Right. Then the same end A, it is 10 mm in front of VP. I will indicate like this. Right. 10 mm in front of VP. Then it is inclined. That is inclined to HP. I will denote it as theta. Okay, the theta value is 30 degree. And inclined to VP is 40 degree. So I have 5 data in this kind of both way inclined problems, right? The 5 data will be given. You need 5 data to solve this kind of problem, right? So this 5 data I have to use this. So what I am going to do, first of all, in the first problem, okay, I am going to assume something, okay, the line is first, I am going to assume the line is only inclined to HP and it is parallel to VP. So I will be projecting that and I will end up with some results, right? Then I will be assuming, in the second case, I will be assuming the line is only inclined to VP, something like this. Okay. The first case I will be assuming the line is only inclined to this, and the second case the line is inclined to VP. Okay, only inclined to VP, right? Then I will end up with some results. Okay, using that I can draw the both way inclined line. Okay, so what I am going to do first, assume line only inclined to HP. So only inclined to HP means I need this true length, this and data. Right. So using that I can draw, if the line is only inclined to HP and parallel to VP, what will be the thing? It will be like this, isn't it? The line is only inclined to HP and parallel to VP means I will obtain the true length and true inclination in my front view, and in the top view I will obtain a shorter length parallel to the reference line. Okay, do you have any clarification in this? Straight away I can draw it by assuming that assuming that I can draw it, I know it is 15 mm above and 10 mm in front of. So this is my A dash. This is my A. Right. So this is. So since I am assuming the line is only inclined to VP, only inclined to HP, so I can draw a 30-degree line. What I have to do? So this is 30 degree. And what length I have to measure it? The true length 75 I have to measure it. So I have to measure 75. So this location. Normally for the problem, separate problem, I will notate it the other end notation. Now I am assuming that the one end projection I know. The one end projection I know. So one end projection I know. I'm going to, in this assumption, that end location is kept fixed. Right. So then I am assuming that the line is only inclined to HP and parallel to VP. This end is fixed. But this end is an assumed end. Okay, this end is an assumed end, so it won't have the final projection notation. Okay, this won't have a final projection notation B dash. What I can give? It is not B dash. Actually, it is not B dash. B dash is here. Okay, so if I project it, the B dash will get. So I am assuming it is parallel and only inclined. So I will have an orbit assumed location of this end. Okay, this end projection I am projecting, I can notate it as B1 dash. Right. So it is an assumed case, that is an B1 dash. Now I can project this. So I will have a, what will be this notation? Top view notation. B1. Right. You see here in this case, the line is assumed. Okay. So instead of the line is some distance above, I am keeping it on the table. Okay, that distance it is above. Right. So you see here, it is assumed like this. So actually the line is inclined one I have assumed. So I have got the projections like this. Okay. So it is inclined 30 degree. So without varying this 30 degree inclination, okay, without varying this 30 degree inclination, I am going to tilt this line to VP also, 40 degree also. What will happen to my top view? Top view, do you have any variation? Top view length, in top view length do you have any variation? This end is going to rotate like a cone, right? It is going to rotate like a cone. So whatever inclination I will tilt, so that top view length, whatever I am going to get of this line, it will be same. So that is the result I will have. So whatever in this assumption I will have, this is my top view. So this top view length is going to be my final top view length. Okay, this top view length is going to be my final top view length. Right. So one thing I have got. in this one, I have got this result. I have got a top view length. The top view length, what is this top view length? It is AB1. AB1 is my top view length. Now on the same assumption, you see here, on the same assumption, so I am going to rotate it. Okay. What will happen to the height of this end? The height of this end from the ground, it will be same. So the height of the end from the reference line will be same. The height is nothing but this. Okay, this height will be same. Okay, for my final view also, this height is going to be same. That height is nothing but my locus. I can say this is a locus of, locus in the sense what? Locus of end B. Locus in the sense what? On that line, locus of a point is nothing but a straight line. Okay, on this line, locus only, I am going to have my final projection of end B. Final projection of end B. So I can say this is the locus of end B. Locus of end B. So in this one, I have got the top view length and the locus of end B. So my final top view has to fall on this locus. My final top view of end B has to fall on this locus. From this assumption, I have got this. Now we will go back to the next assumption. So I can assume, the next one I can assume the line is only inclined to VP. Right. So in this assumption, the case will be like this. The line was originally it was like this. Okay. What I am going to do? I am making it to parallel to HP and it is only inclined to VP. Okay. So in this assumption, I will get two results. Okay. Using these both two results, I can draw my final front view and top view. Right. You see here, in this one, I will have the one end which is fixed. Okay. That end location is going to be the same. A dash and A. Right. The other end as per this, it is only inclined to VP. I can draw it like this. Right. Right. The same locus, the end will be here. In three separate steps, I am going to draw it. So this is my end A dash. This is A. It is fixed line. Right. So as per this assumption, the line is 40° inclined. What length I have to mark it? What length I have to mark it? 75. That is true length I have to mark it. This is 75, right? So true length I have to mark it. So this is 75. Same 75, I have to mark it. This is my, is it a final end, top view end? No, it is an assumed end, location of end B. So I can give a notation of B, B dash and B. B2 I have to give it, right? It is the top view. Okay, without that I have to get it. So and it is an assumed one, already I have given B1, so I can give another one B2, right? But it is not an front view, it is a top view, so it is B2. So what I can do, I can project this. Okay, this angle is 40°, so I will get a line parallel. So what will be this notation of B2 dash? So in this case, on the same fashion, okay, I will have two results. Line is only inclined to VP and parallel to HP. Right. Without changing this inclination, I am going to tilt this to. Okay, I am going to tilt this to inclined to HP also. So what will happen? The front view length, okay, whatever front view length you are going to have, okay, that front view length will be same for the final projection. Okay, here the front view length, this is the front view length, it will be the same for my final projection. Okay, and similarly this end, the other end B, whatever distance it is in front of from the vertical plane, even though if I tilt it, okay, it will have the same in front of distance length. Okay, that is nothing but the locus of the end B. Sorry, this is locus of what? Huh? B or B dash? B1 dash, these are all arbitrary locations. The final projection, okay, what is? B dash. Okay, locus of B dash, wrongly. This is locus of B dash. Right. So what will be this? This will be locus of B. I have got a locus of B and I have got a front view length. So in the second step I have got these two results. The first one is top view length, sorry, front view length I have got. Front view length is nothing but what is the front view length? A dash, B2 dash, right. Then I have got the locus of B, right, I have got the locus of B. So by assuming these two cases, okay, so I have got 4 results. Using that, I can conveniently draw my final projection. So the final projection, if you see the final projection is here. See the final projection. Final projection, how we can draw it. So this is the final projection of the line inclined to both cases. The end A location is same for the final projection also. You see here, this is going to be my end A dash and A, right. So what is the front view length? Do you have the front view length for the, you have the front view length here. In this result I have the front view length. What is that front view length? It is A dash B2 dash. You have this length, okay. I can measure this. Just I can measure this and I can have what I can do, I can rotate it to the locus, okay, locus of B dash, wherever it intersects, that is nothing but my front view, okay. So what I can do, I can measure the front view length, okay, I can cut it on the locus, I can measure the front view length, I can cut it on the locus. This is my what? B dash. Is it clear? So it is nothing but this will give me the final front view. This is going to be my final front view. Is it clear? So what I am doing, just I am rotating this front view length, keeping A dash, just I am rotating this front view length to the top locus, okay, locus of B dash. So wherever it intersects, that is my B dash. So this is my final front view of the inclined case, given problem. So how I can draw the top view? So what I can do, from this one without measuring I can do it, finish it off. What I have to draw it? I can draw a projector line, that's it. Okay, I can draw a projector line from B dash, wherever it intersects the bottom locus, okay, that because end B projection will fall on the same projector line, okay. So B and B dash and B will be on the same projector line. This is the location of my B, right. So I can draw it, join it. So you can cross check what should be this length. It is top. What? This is the top view length. Okay, what is the top view length? I have already AB1. If you measure this AB1, that is going to be that length. Okay. This is going to be the final top view. If I measure this top view length, that is AB1, that is going to be my final this length. Okay, so both are same. Final top view length is AB1. Either you can measure this final top view length from A, I can cut it to the bottom locus. It will exactly intersect this B. Okay, that B and B dash will fall on a same projector line. So this is how we will be solving this kind of problem, string problem. What we will be doing, first we will be drawing, assuming this, we will be drawing, assuming this, and we will be rotating. So both the three separately drawn drawing here, it will be drawn on the same place. Is it clear? It will be drawn. So that is 10 mm, 15 mm, and 10 mm. So this is A dash, this is A. I can mark it right. Then first assumption, as per first assumption, it is only inclined to HP. So how I have drawn, it is both these two cases are in 2H pencil. Okay, both these two cases are in 2H pencils. Okay, final view alone it should be in a H pencil. Okay, the same way the 30-degree line I have to measure it. So this will give me the 75. This is my B1 dash. Right. These notations are very important. Okay. Then and there, once you have drawn, you have to mark the notation. Otherwise, you will get confused. So B1 dash, the first assumption. Then, by projecting this, I will have my top view in the first assumption. So this will be my B1. Right, as per first step it will be B1. So this angle is my 30 degree. Neatly you have to dimension it. This is 30 degree. So what is true length here? 75. That you have to dimension carefully. You have to dimension using your drafter. You have to dimension it. So dimension the 7. So this is 75. Right. Then in this results I have got a top view length and I have got a locus. I have got a locus. You have to neatly write locus of B dash. Locus of B dash. Right. Then you have to go for the second assumption. Second assumption is this is the first step. Okay, second assumption is 40 degree incline. It is 40 degree. This second notation is it is B2. It is B2. Right. By projecting this, I will obtain on the same location. I will obtain my B2 dash. Right. This is B2. I will obtain B2 dash. So in this second assumption, I will got my front view length. And I have got my locus of B. Right. Then with this step, just I can tilt my front view length. I can rotate my front view length to the top locus. Using this as center. Okay. In your compass, using this as center, I can rotate my top view length to the bottom locus. Wherever it intersects, okay, that is going to be your final end of the projection location of the end B. Right. See here, this is by rotating this. So it will intersect somewhere here. This is my location of B dash. By rotating this. So this is going to be my final front view. Right. What I can do to draw the top view? Either I can rotate the top view length to the bottom locus, or I can draw a projector line from this end can draw a projectile line from this end. Right. This projectile line, wherever it meets, okay, that is my D, final D. Even though if I rotate this A, B1, the top view length, it will exactly be here. Right. So this is going to be my final top view. Right, is it clear? This is how you have to draw the both way inclined problem on a single place itself. Right, so this, then whatever data given, it is 5 data are given. Okay, what are the data given? 5 data, that data has to be placed carefully. So this is 30 degrees, 70, this dimension is given. Okay, what is this? 10 and 15. This is 10, this is 15, this is 10, okay. Right, then whatever data, this is marked, 40 degree is not marked, okay. 40 degree I have to mark it, so 40 degree, carefully, using this as center, using compass, carefully you have to draw an arc to the true length line. So this is my 40 degree. So you see here, the true length and true inclination, where you will have the true length of the straight line in a given problem, it is nothing but my A dash, B1 dash. The same true length I will have in another location also, where A, B2 also gives the true length. True inclination, 30 will give this, it will give, right? So this inclination, whatever I have the top view, that is an apparent inclination. Okay, this inclination, I can say the top view inclination, this is apparent inclination of the top view, it is notated as B, beta, right? So the apparent inclination of the front view I will have, okay, that is notated as alpha. So I will have two notations apart from this, okay, alpha and beta. So this how you have to fully finish the problem with all the details, okay, whatever given details, 5 data, you have to dimension it, carefully notate it, okay, dimensioning carefully you have to do it, the rotations carefully you have to do it, right. Then you see here, the locus of beta you have to write each and everything, you will be getting marked for this, right. Listen. This is a straight away problem of both way inclined problem, okay. In straight line problems, okay, you may get like this, but you may get any of the 5 data used in this problem, okay. So whatever possible data I can give for a straight line problem, you have to know that, okay. I can write the possible data given in a problem. Make a note. So what are the data can be given in any problem? The first one is the true length can be given. Okay, the true length can be given in a problem. TL is nothing but true length. Right. Then true inclinations will be given. Say theta will be given. Theta is what? Inclined to HP, right? True inclination to BP will be given in a problem, right? May be given in a problem. Then one end location is given, say A, end A. End A above distance. Above distance may be given. So similarly, end B, end A in front of distance may be given in a problem. Okay, this is the 5 data in a straightaway problem it is given. Right, apart from this, there is a possible data I can give an end B above data. So what is the end B is above data? Here in this one, what is the end B is above data? So end A is above data is nothing but A dash location from the reference line. What is B dash location from the reference line? That height will be given. That is nothing but what? Locus. Okay, that is nothing but the locus height. So end B is above distance is equal to nothing but locus of B dash. End B is above distance. It is locus of B dash. Right. Similarly, I can have a data of end B in front of distance. What is that? Locus of B. Okay, locus of B. So this data will be given. So maybe the other one. Alpha will be given, may be given into a problem. Alpha is what? Front view inclination. Front view inclination. So 9th one, beta may be given in your problem. So that is top view inclination. So front view inclination, these inclinations are apparent inclinations. Right. So apart from this, there will be a data. You see here, what is the distance? So this is nothing but my 1 inch projector. Right. So B dash, I will have another inch projector. Right. I will have another inch projector. Right. So the distance between these end projectors may be given in a problem. You see here. This is nothing but the distance between the end projector. I can say this is E, the end projector's distance. Okay, distance between end projector. End projector. Distance between end projector. Then we have missed. Front view length can be given 11. Front view length may be given. What is front view length? Front view length in this problem is A dash B2 dash. So A dash front view length if it is given in a problem, what you have to draw? Just you have to draw a horizontal line A dash B2 dash. So to that length you have to draw it. From that you have to enter to the final position. Similarly, a top view length would be given in the problem. A B1. A top view length if it is given in a problem, you have to draw a horizontal line below the reference line, that is A B1. That you have to mark it. Right. So apart from that, I may have the location of a horizontal trace also to be given. Horizontal trace. So I can have a location of an vertical trace. So you see here, these are all the possible data. So using this, any 5 data will be given in your straight line problem. So what you have to do, that 5 data in this will be given in your problem. That 5 data, carefully you have to write it like this. Okay. Carefully you have to write it like this. That 5 data, you have to draw it using this as a template. Okay. This as a template. I can place the 5 data first of all. Then there will be asked, some data will be asked. Okay, according to that you can use the procedure, you can reverse the procedure, something you can end up with this one. Okay. So the data will be asked in this. Is it clear?